I'm Jan-Simon Moeller. I will talk a little bit about software bill of materials in Automotive Grade Linux and how it relates to CVEs, to the CRA, and what we do, what we will do, or plan to do. Geez. I'm the release manager. I'm also doing the continuous integration and automated testing infrastructure, and doing code reviews, making sure everything works together. So, first I want to get everyone onto the same page. SBOMs, CVEs, supply chain. So I'll give a quick introduction what all of that is, and then we take a look at what is in the current stable release, which is the terrific Trout release. Basically, what you have now in front of you if you build AGL. And then we will go and look ahead. What does upstream Yocto project do right now in its master branch? And essentially next spring, we will upref the code base to use the new Yocto LTS, right? So this is basically a look ahead to next spring and what will come then. I'll point to a few tools or show the tools landscape, and then we'll do an outlook. Okay. So SBOM and CVEs in general. So an SBOM, what is a software bill of material? Let's say it's, and I try to, well, summarize and simplify here. It's a detailed inventory of the software that we either source from a supplier, right? So we want the software that we are going to use, but also we want the SBOM of the software, right? So we will need to know exactly what's in there, what libraries are used, and so on. Well, we can also do an SBOM for the software that we build ourselves, right? What libraries and stuff is in there. And once we assemble everything into a final image, yes, that's basically a composition of all the software. So there's an SBOM, and that ends up in the final product. In principle, we try to preserve a lot of metadata along the way, right, from building, from the source, right? The source is, well, the sources, if we download an AGL tree, let's say the sources are about, let me think, I think it's around 20 gigabyte, right? Once it's pulled down, still compressed, yada, yada. So that's a lot of information, right? And then we build stuff. That process contains also information, right? But in the end, we get a binary, right? So, and compilers are really good at compressing, essentially, right? So by producing the final image, we lose a lot of information. Good. So essentially, SBOM to the rescue here. An SBOM contains a lot of metadata. What software packages are in there, what versions, it can have hashes of files, and so on. And all of that is defined in the SPDX format. It's actually a data, a transport format. Yeah. And we can then, with that file, we have all the knowledge, what versions are in there, based on that single file. We don't have to go into the final image and inspect it and maybe find what version and then go back to the sources and so on. So just by keeping that information around as in the SBOM, we can then go and say, okay, is there a new CVE that applies to my image? Right, so this is one use case. Another use case is license compliance, right? The software in my image, what are the licenses of that final image? Those are different aspects that can be fulfilled with the SBOMs. Okay, so next, CVEs. So CVEs is basically a database that contains a catalog of vulnerabilities that are known. They are then classified. We know the versions affected. It lists the disclosures, the security announcement. And in principle, it is and was used as the reference for all of that, right? It's a lot of work, right? Someone did it, and everyone was, yay, good, fine, that we don't have to do it. Now, there were some funding problems in April. Yocto project, for example, we noticed that quite heavily because if you did the CVE checks, you had problems pulling down the database, right? So we were scrambling to find an alternative source for the database. Yeah, so things are moving here. There are initiatives to do extra funding, but on the other side, there are also initiatives to do an alternative, complete alternative. Well, why? We get to kind of the CRA in one of the next steps, but as part of the CRA, in that regulation, there's a mandate, or, well, points to, well, don't have a CVE in the product when you ship it, is kind of, right? So they reference this, and now they might lose the source. So they scramble to have an alternative. End of the story. Yes, the landscape is evolving quickly, but the tooling is having a very hard time to follow that, right? Because now this database might have a slightly different format. Okay, we have to adopt the parser, right? Another one, okay, now I have a second source to follow, right? And do they match, do a mapping? And so that will follow us for quite a bit. And I assume the tooling will evolve, right? But it will be a little, I assume, a little rough ride. Yeah. But we have to, kind of, it's part of the regulations, so industry and regulators scramble to fill that gap. Supply chain regulations. So there are regulations going on in the EU. That's more on the hardware side, but then there's a Supply Chain Act in Germany. There's a similar effort in Japan. So that is, in the end, not just about hardware. It's also applied to software in the end, right? So you have to have an SBOM to fulfill supply chain regulations in the end. Here it's kind of keeping track of the composition of the sources of a software, not just for licenses, right? The original intent was license compliance, but things evolve here. So we basically have the software supply chain and the SBOM being the way to document that. Things evolve. So SPDX comes out of the license compliance corner originally. Yeah. There is another format, Cyclone DX, that comes out of the vulnerability scanning corner, right? And things kind of emerge into the same space here. The CRA in the EU and a counterpart are the cybersecurity management guidelines in Japan. Essentially, it means cybersecurity is becoming an obligatory thing. They are not optional. I tried to summarize kind of the CRA in a nutshell, right? Security by design, right, means you don't have kind of an open password, right? Root. You need to be conscious and have your software done with that in mind. But now comes the process. You need to do a continuous vulnerability handling. What does that mean? Well, you have to watch out for new vulnerabilities in your software, right? And if a new CVE comes out, you have to say, oh, that applies to X, Y, Z. So you need to be able to trace that and handle it. It mandates, for example, 5-year minimum security updates for 5 years without delay. What delay means is now a different story, but let's say 30 days is kind of long, right? So a kind of reaction time of a month, I think, is the minimum. Correct me if I'm wrong there, but I think that's... and your updates must be distributed securely. Paper trail, so there must be assessments, there must be the SBOM, so that's in the regulation already. And for certain things, you have to report sometimes within 24 hours to an authority. Now, that's the CRA part. It might be likewise in other jurisdictions. What means is this becomes an essential part, and especially this here means a continuous handling. It's not just, develop, black box, ship, and forget. Oops. We cannot just say, okay, we are done. It's a continuous process. Woo. View, slideshow. Okay, so the first bits are basically part of the development pipeline, and essentially, starting here, we have a feedback loop, right? Or a processing that needs to happen. Different angle, functional safety. So regulations require certain certifications to a product to have certain certifications, being it automotive, medical, pick your poison. Essentially, there are different levels with different rigor based on the use case. Good, so far. That's very high level, very brief. In principle, it requires a kind of lengthy process. Yeah, we've seen the MISRA talk just before, and for functional safety, there is even more, or also things that you need to do in hardware, not just in software. So usually, well, the software was frozen, right? You freeze your software, you do all the processing or analyzing, and then, okay, done, stamp. Yeah, now we have a conflict here, right? Remember, without delay. yeah, versus rigor and possibly software freeze. Right? Now we need to scratch our heads. Because we need to do updates without delay, and we have our requirements on functional safety, which, let's say that process previously took half a year. And now I have an answer time on the security side of a month. So by the time we get the software out after half a year, I have 5 more in the queue, essentially. So one idea that is being discussed is if we can kind of get more information as part of the SBOM here, we know exactly what really changed, right, in the binary side, without diffing the images, but we can move more information from the build stage, right, into the SBOM and analyze that instead of looking at the binary images. So one thing that's discussed, we know then what did not change, right, and can be a more fine-grained analysis of the functional safety aspects, not kind of the whole image, more fine-grained. Yes, there can be interactions. Yes, you need to do testing, but maybe you can be more fine-grained here to speed up that process. Also, with the metadata you can have of the units in the field, you can have kind of a representation of all that metadata and say, okay, this whatever car uses exactly this software, and we applied this, and that. This gives a resulting SBOM, and we put that through the mill. The problem that I see is currently we still have kind of siloed processes, right? We still have kind of CVEs on the one side, we have license compliant on the other side, we then redo a lot of similar tasks in all of these areas, essentially. It's not the same, but similar. Essentially, the tooling landscape around SPDX, CVEs, license scanning, vulnerability scanning is evolving, but we are far from done. Yeah. And there is no single rule, right? There is no single tool, yeah, no ring to rule them all. There is just no tool currently that will cover all aspects. Yeah. Also, integration into our workflows might be a challenge. Yeah. And if we do kind of single siloed workflows, that will not scale. We will kind of do work twice or triple, right? And then that times X will just amplify and be a lot of work. Okay. Now let's take a look at what is there currently in Trout and where we are heading then next. Okay, so Terrific Trout is based on Yocto Project ScarfGap 5.0.10. We are using these components here, Flutter, Qt, and so on. So, what is available in terms of SBOM in the Trout release? So we are based on the create SPDX feature of Yocto itself. And in scarf-gap, that will produce SPDX 2.2. Yeah. SPDX, and you can enable it with the switch AGL create SPDX. It will create an SPDX file for each package that we are building, and there will be a tarred up collection for the image. There is just an index for the image. So we cannot combine all of these SBOMs in the 2.2 format. Yeah, we can produce individual image SBOMs. That index contains references, right, to these package SBOM files, but we cannot produce a single image SBOM with 2.2. That had to do with hashes that are embedded in there, and if we kind of create the image SBOM, those would have to change, so we had kind of a chicken-egg problem within the SPDX format. So current state is essentially we produce an SBOM for each package. We have an index file that references these, and they all get basically tarred up over here. Now, there is no tool that can, well, it's left to the guy that needs that data, how he parses it, right? This is not the final solution, right? This is just the transport format. Yeah, here is the stuff. How you parse that, how you put it into whatever database, something, and do stuff with it, not my business here. This is just the transport format in the end. Okay, so we had the problem there is no single SPDX file for an image, right? We had to collect the package SPDX file and put that into an archive, essentially. That archive is rather big, 14 megabyte, heavily compressed. So untarred, it's probably 100 megabytes or hundreds of megabytes. Back then, I didn't know of a tool that could digest this, right? So we were kind of the first penguin in producing an image SBOM, full image SBOM, with kernel, with user space, with application. I wasn't aware of a tool that could basically read the index that references all these files and parse it. Okay. Also, in SPDX 2.2, there was no way to add information about CVEs or about handled CVEs, right? The package version was recorded, right? So we would, if we then check for a CVE, we would see the package version and say, yeah, this package is vulnerable. But there was no way to say, but we applied a patch already. That was added by Yocto, but it was kind of a special unicorn solution. They used a comment field to say, we handled this, we handled this. Okay, so that's 2.2. I mean, the general idea is with the SPDX, we produce an image or we produce a software collection. Here is the SBOM for that, right? And then you need to grab that SBOM, read it into your tooling, and analyze it. If you do that, you can reuse a lot of the platform, right? And work on top without redoing all of that. Okay, so what can we do? We can create the image SBOM, but only as the index that links to the individual packages. We enabled that roughly 1.5 years ago, right? Once we switched to scarf-gap. So, yeah, the tooling problem. We could verify an SBOM. So I could go take the package SBOM, put it into the verifier, and it would say, yes, valid SPDX. Yeah, okay. But also there is no good process to process and reuse the data, right? So the ecosystem needs to evolve for us to proceed here. On the CVE front, there is the CVE check class. So this will, it's easy to enable. It will pull down the CVE database. It will then basically compare what we built against the package and version information in the CVE database and say, hey, during the build, your package is vulnerable, or you get a report in the end, right? Your image contains XYZ CVEs. Now, it's rather easy to enable, but we had, especially in the last half years, issues with fetching the database, right? So that's why it's not enabled. It's a huge increase in build time. So this is a recent number. So this is just 20 minutes, which is, okay. Not too bad, but this was up to like 4 or 5 hours in April, because it had to retry. This was no fun. And then you get basically unpatched CVE information out. Good. So that's the homework, to go through them and say, okay, it doesn't apply, applies, we need to fix. Okay, so that was the look, what is in the current Trout release, and now let's take a look ahead, what is in front of us. So if we look at the upstream Yocto project now, latest development branch, we have SBOM is no longer an option. It's enabled in the default configuration. Yeah? So it is enabled by default. We are meanwhile actually using SPDX 3. Now, SPDX evolved. There is now a revision 3. And that was developed to solve some of the problems, exactly some of the problems that we saw previously. Right? We can now include CVE information. We can now include, we can now actually produce an image SBOM. Yeah? We have different profiles for tools that scan the source code. We have a build profile. This is what Yocto uses. So we have different means. We can also enhance an SBOM, maybe with a different tool, later on. Okay. So Yocto is basically taking an active role in the SPDX community and spearheading the development here. There is also a bridge to the CVE world now. So essentially the SPDX that the SBOM file that falls out of this process will contain information in the VEX format about the CVEs that apply to that image. So it's now not separate, it's part of the SBOM. Before that, it was a JSON file somewhere else, right? So now we're getting things together. And what's also new is we can include the sources in the SBOM. And an even more interesting one, we can add the compiled sources into the SBOM. So only the stuff that's actually compiled in. The missing single image file is now there because we can reference the individual packages with a unique ID. And we added the CVE, the missing part that was added by Yocto as a comment, essentially, is now part of that format right away. Okay, so when will that come? It will come in spring 2026. Help me with the name, Scott. Rhinos. And it will have this right away. So here's now the thing. That is all being enhanced and prepared. But if you find a gap, now is the time to work with the Yocto project and SPDX to actually get any missing bits resolved, right? So the next release is just in development now and not released. So if there is something missing, go look at it and see if it fits your bill now, right? Because we can still influence upstream and maybe add a field or do something about it. Come spring next year, we want to be there and just turn it on. So I did some experiments with Yocto Project Master and Core Image Minimal. So step by step, get Pokey. We just set up a simple environment, x86, QEMU, just stock stuff, and we enable two things, create SPDX and CVE check, right? We want the extra information in there. And there are some exclusions, kind of well-known exclusions that have been already curated, right? Just to tune down the noise. Okay, so 3 lines. We end up then with, and that's the difference, a single JSON file in the SPDX3 format, okay? Which contains all the information for the image. So not an archive, not individual package files, one single file. And there's also some CVE information included here. So it's now both. You don't have to look at the SBOM and then at the CVE JSON, and so that's easier. Okay. Now what about the new features here? We can include the sources or the compiled sources. Let's take a look. Yeah. So we see the original image JSON was 4 megabytes. If we include all sources, it's 1 gigabyte, right? We asked for it. Now think of it. In turn, this means you get everything, yes. But it also means you have to digest all of this into your tooling, right? You need essentially at the other side, which I don't care because my task is just to produce the transport, the data, right? You have to read that in and parse it. And just the compiled sources is smaller by about 300 megs. This one is actually quite interesting, right? Because it can rule out code which is not in use. So this might actually be quite interesting. Basically the landscape of the ecosystem, 5?
Yeah,
less than 5. Okay. Yeah, that's fine. The landscape is evolving. So we have tools that come out of the license compliance area like Fossology and SW360. We have also tools that come out of the vulnerability CVE corner. So things are evolving, but it's kind of, we are still at the level tools, build tools, right? Don't expect the tool to solve all the things here. Cyclone DX is also a format that's used for the SBOM. There is a layer that kind of does the mapping into the other format. And as an example, how the tooling can parse such an SBOM, there's a vulnscout IO tool, which builds on, for example, Gripe, which is one of the other tools. So this is a superset which can parse an SBOM. So for example, I gave you a quick intro here. It is using a Docker container in the end. So this is the config file. It points to the JSON, right? So this is the JSON, and this is the CVE, which is essentially the same. And then you call that thing. It reads it in. It's actually a web UI. And you can see, OK, I don't care about what's fixed, where we are not affected. I want to see what's pending analysis here, right? So I only see these, and I think we end up with like 40. Yeah, so interesting, the tooling landscape is evolving, but we are not completely there yet. So what do we have? We have really good support to produce SPDX 3.0. Yeah, a shout out to Joshua Watt. He's the primary guy behind that and interacted with SPDX and did the heavy lifting on the Yocto side. But now we need to integrate the tooling and get our pipelines ready to work with that, right? And if there are gaps, now it's the time to help out on the Yocto front. And in the end, yeah, the tooling and our workflows need to evolve, right? Because you need to be ready to digest that gigabyte of data in the end. Yeah. So you asked for data, here you have it. All right. Any questions?
You can ask me questions later.
Yes, I will be on. Thank you.